Welcome to this video on logarithmic functions part 3. In the first video, we converted between logarithms and exponents. In the second video, we learned to evaluate logarithms and also use the ability to convert between logarithms and exponents in order to solve basic logarithmic equations. In this video, we will become familiar with two logarithms, the common logarithm and the natural logarithm. Let's begin. In math, you're going to see something that looks like this, log x, and you might also see something that looks like ln of x. So what are these two things, and what do they mean? One thing that might jump out at you is that neither of them specify a base. So far, in all of our videos, we've always had a number down here, like 2, or maybe, 7, something. There's always been something there. So what does it mean if we just have the log of x and there is nothing written down here? Do you want to guess? Well, the standard notation just means that it's the log base 10 of x. Do you know why we use this as our standard log? Well, the reason is because we have a base 10 number system. So anytime you see the log of x without any base written, you can assume that this is the log base 10 of x. And this is called the common logarithm, or the common log. All right, let's explore this other guy, ln of x. What does that mean? Well, it means the natural log. But you might think to yourself, well, if it's the natural log, why isn't it NL instead of ln? What is that about? Were they just going for symmetry because the other log begins with an L? Well, the actual answer is that this was done in French, and like many Romance languages, French puts the noun first and the adjective second. So instead of saying natural log, they would say log natural. So that's where the ln comes from, is because it was, I guess, developed by someone whose native language was not English. Okay, so ln stands for log natural, or logarithm natural. But what is the base of ln? Well, let's go to the next page to really explore that idea. So as you can see here, I wrote out the common log function. Again, log base 10 of x is log of x. Then let's look at this natural log function, right? So again, ln stands for log natural. So this says it's the log base e of x. But what in the world is e? What is this thing? Well, as you can see, it says the number e is a famous irrational number, and it's one of the most important numbers in mathematics. So remember, the definition of an irrational number means that it cannot be expressed as a ratio of two integers. Okay? So if I just looked at the first few digits, right, if I just kind of did a snapshot, doesn't it really look like there's a pattern? 2.718281828. Your brain might think, oh, it should keep going, 182818. And the most unfortunate thing about this is often those are the only digits that a handheld calculator is going to display. So again, if you're just looking at it in your calculator, you may well be misled to think that it has a pattern. And the reason that's important is because anytime you find a pattern in your decimals, usually that means that you have a rational number, not an irrational number. But let's look at what actually happens after that last 8 there. Right now you can see it kind of diverges, and there's not actually a pattern. Okay, so remember, one of the definitions of irrational numbers is a non-repeating, non-terminating decimal. Okay, and by repeating, I mean there's a pattern, right? There's a fixed finite set of numbers that repeats over and over and over again. That is not what e is. It is a non-repeating, non-terminating decimal. It's called Euler's number. Now, whenever I saw this first name, the first time I saw it, I was like, oh, Euler's, right? Because that's how we would pronounce it in English. But again, it is pronounced Euler. I don't know what language that is, but that's how they pronounce it. Okay, so we just need to get familiar with these notations, right? Log x means log base 10 of x. ln, or natural log of x, means log base e of x. So let's use this next page to practice and familiarize ourselves. Okay, so we have the natural log of x equals y. Okay, so what we can do is we can remind ourselves that the base is e, right? So this is the same as saying e to the y equals x. Okay, and if you're like, wait a minute, where did that come from? Well, let's just review and remember. E is our base. Y, right, the value on the other side of the equal sign is our exponent, right? So that's why I wrote e to the y, not e to the x, right? And then x, right, is the result. This is the result of raising e to the y power. Okay, let's keep going. Again, I encourage you to pause this video, try some of these examples on your own, then unpause it, maybe even speed it up a little bit and check your answers. Okay, so the natural log of 2 equals x. Again, this is log base e of 2 equals x. So e is our base. Remember this number or value over here, in this case x, is our exponent. So we have e to the x power equals 2. Okay, let's keep going. This says the natural log of e equals 1. Well, what does that mean? Well, the natural log is the log base e of e equals 1. So in other words, e, that's our base, okay, to the first power, right, that's our exponent. So e to the first power equals, this is our result, which kind of makes sense, right? Anything raised to the first power is just itself. All right, so now we have 3 practice problems with just the log. This is the common logarithm. Do you remember what the base is? Well, the base is 10. So let's just write 10 in here, okay? So this is 10 to the n power equals m, okay? Again, remember this is your exponent, right? And then m is your result. Let's keep going. We have 10 to the second power is equal to 100, which makes sense, right? 10 squared is 100. And then we have 10 to the negative second power is 0.01. And if you're confused by that, right, it's absolutely true, right? Because remember, 10 to the negative second power is 1 over 10 squared. Well, what is 10 squared? 100. And 1 over 100 is 0.01. So it really is true.